So what we're looking at today is chapter 2.6. This is the last section in chapter 2. Now there are two theorems we're going to look at here first. These two theorems here are going to be helpful once we start moving on in the rest of the year. Now the first one is the congruent supplement theorem, this one here. If two angles are supplementary to the same angle, or two congruent angles, then they are congruent. So what this is saying is if angle 1 and angle 2 are supplementary, it means they add up to be 180. And 2 and 3 add up to be 180. So what we're saying here is the measure of angle 1 plus angle 2 equals 180. And 3 plus 2 is equal to 180. Well, they're both equal to 180, aren't they? So really I could say that 1 plus 2 is equal to 2 plus 3. Well, 2 is the same in both of them. So we can say that 1 is equal to 3. We can look at it a different way. If we said that this was 40 and 140, well, those two add together to be 180, yes? 40 plus 140 is 180? Yes. And we say that these two here are supplementary, so 140 plus angle 3 equals 180. Well, if we subtract 140, we see that angle 3 is 40. These two have to be the same. If 1 and 2 are supplementary and 2 and 3 are supplementary, 1 and 3 have to be the same value. 1 and 3 have to be the same value. Now, the other one we have is congruent complement theorem. Well, two angles that are complementary, they add up to be 90. So the same property is true for complementary angles. If 4 and 5 add up to be 90, and 5 and 6 add up to be 90, well, 4 and 6 have to be the same. 4 and 6 have to be the same. Now, what we're going to look at is more proofs. We're going to be looking at more proofs today. Now, this here is our first one. This is a flowchart proof. Now, we've looked at two column proofs, which is just two columns going down the side. We've got one where we're kind of stating or doing our proof, and the other is our reasons. Now, in a flowchart proof, we're going to write the reason underneath each bubble. So it's going to be bubbles leading across to where we're wanting to go. Now, we always start with what? The given. So the first bubble will be the given. Angle 1 and angle 2 are right angles, because that's just what? Given to us. And the last bubble should be what? We're wanting to prove, yes? And what are we wanting to prove? That angle 1 and angle 2 are? So that'll be the last one. That would be the last one. Now, if we said that angle 1 and angle 2 are right angles, what does that mean? So what would their measure be? Their measure would be 90 degrees. Their measures would be 90 degrees. Their measures would be 90 degrees. So angle 1 and angle 3 would both be what? 90 degrees, yes? So we can say the measure of angle 1 is equal to 90, and the measure of angle 2 is equal to 90. Well, since they're both equal to 90, what can we say about them? That they are equal to each other, because of the transitive property of equality. Since 1 is equal to 90 and 2 is equal to 90, it means 1 is equal to 2. And since they're equal, it means that they are congruent, because if two angles are congruent, it means that they are equal. They have the same value. And we're done. That's all we have to do for this here. Now, flowchart proofs provide a more logical way to write a proof because we're saying this, since they're both right angles, leads to the fact that they both equal 90. The fact they both equal 90 means that they lead to that they're equal to each other, which means that they are congruent. It's just a flow of thought. We're going from one to the next to the next. So when we look at this next one, there are a few more bubbles, and this works when we look at this here, and I'm going to change some of the arrows, and you all can fill in how I change them here. Move this over here. We look at this here. So again, with any proof, we always start with the given, yes? So our first line, well, it says angles 1 and 2 are supplementary. This is our given. Now the other given is that 1 and 3 are supplementary. And really what we're doing here is we're proving that 2 and 3 are supplementary. Our theorem that we just got a minute ago is what we're proving here. Our congruent supplementary theorem. Our congruent supplements theorem. So we have these two givens, and we're going to end up saying that 2 is congruent to 3, yes? That's what we want to prove. Are we good with everything so far? Yes? Now, if we said two angles are supplementary, what does that mean? They add up to be 180, yes? So let's use that. And we'll use it here. Because since they said they're supplementary, we know they add up to be 180. So let's use that. Just use that information, because that might be helpful. Because they add up to be 180. It means they add up to be 180. So we can say it about both of those. Any questions on anything we've done so far? We good with this here so far? Yes? Now, as I said earlier, I'm going to rewrite one of these arrows. I don't agree with that arrow there. Really, if I were going to draw an arrow, I would draw it to here. Because we're using the fact that both of those equal 180, yes? Both of those equal 180. So really, I could say that measure of angle 1 plus the measure of angle 2 is equal to what? The measure of angle 3 plus the measure of angle 1, yes? We can use those two together because they both equal 180. And that's what we're doing. We're using our transitive property of equality because 1 plus 2 is equal to 180 and 1 plus 3 is equal to 180. So we can say that 1 plus 2 is equal to 1 plus 3. Did y'all see that there? Because this one led us to this one, which we use down here. This one led us to this one, which led us to that one. So both of those ended up going together. Y'all see this here? This is where I think flowchart proofs work very well because I can have those running kind of parallel to each other. Now, since we're just talking about measures, the measures of these angles, on this here. Since we're talking about the measures of these angles, this is 1 and 1 are shared in both of them, yes? And they're just a number. So what I can do is I can subtract the measure of angle 1 from both sides and get what? That the measure of angle 2 is equal to the measure of angle 3, yes? And that there is our property of equality, subtraction property of equality, because I subtracted that angle that's the same on both sides away. which got us this here. So is that what we wanted to prove, that the measure of angle 2 is equal to the measure of angle 3? So it's congruent. Well, if two angles are equal, it means that they are congruent. If two angles are equal, it means that they are congruent. Any questions on this here? Yeah. Any questions on anything we did for this one here? We good with this one here? Let's look at another one. So this one here, we've got this here, and now we have a few blanks missing, so we're going to start with those. Now again, we always start with the given information, what was told to us. This here is our given information. This is what we want to prove. So we have our given information, and what do we want to prove? So angles AB and BC, or so line AB, segment AB and BC are perpendicular. DC and BC are perpendicular. And we want to say that angle B is congruent to angle C, yes? Perpendicular. Perpendicular. So we're saying segment AB is perpendicular to BC. DC is perpendicular to BC. And lines that are perpendicular form what? They cross at what? They cross and make what? What kind of angles? Right angle. They cross at right angles, yes? So that's kind of helpful. And we're wanting to say that B and C are congruent, yes? So we need to say something about angles B and C, yes? So AB and BC are perpendicular, so they make a right angle. So what do we know about angle B? Angle B is equal to 90 degrees. So they're both equal to 90, so I'm going to add a mini step in here just so that we have it. So really what are we saying? Angle C is equal to angle B because of our transitive property of and because they're equal, it means that they are congruent. I believe the textbook would probably go more along the lines of saying that in this blank here, we're saying that C and B are both right angles, and since they're both right angles, it means that they are congruent. But we added that little step in there. Because again, we're saying that they're equal. Since they're equal, it means they add up to be, or they end up being congruent, not add up. But since they both are 90, they're equal to each other, so therefore they are congruent. Any questions on this here? Is this starting to make more sense as we work through more of these? Yes? All right, so we're going to look at the next one. This here. Given the flowchart proof, write a two-column proof. So have they given us everything for this proof? So they've given us all the information. These are all the steps here. We just need to write it as a two-column. So what's the first thing that we have? So perpendicular to BC and perpendicular to DC. And why do we know that? That was given. Because it also gave us the reason there. It's given. Because we're going straight down the line. So that's one. Now what did they do next? Our next statement would be what? Definition of perpendicular lines? That B and D are right angles. This is the definition of right angles. So it's almost, we're just listing them straight down, yes? Yes. Mm-hmm. What would you fill in as the third step? Angle B is congruent to angle D. All right angles are congruent. And that's what they used on the last one also. That's why they could skip that kind of in-between step that we did, is just using all right angles are congruent. And we stepped it out. We said that they were, because they're equal. That is, yeah, it messes with my voice. Oh well. All right, guys, so what are the directions on this next one here? Proves that two angles supplementary to the same angle are congruent. So this time we're going from a two-column proof to a flow chart. So we're going from two-column to flow chart. Now they gave us the two-column. They already gave us everything. And the first thing I always start off with is the given information. That angle 1 and angle 2 are supplementary angles. I am abbreviating this because I just won't have the space to write this all out. Now we also know that angle 3 and angle 2 are supplementary angles. Now how did we know both of these here? It was, that was just the given information. So you can write this down below. I would write it below that two-column proof that you have written there. And I would start off as far to the left as you can. Because we're still going to have more bubbles than this. Look, we got to use all this here. It's not that bad, Castle. Huh? Okay, so the first two things we were given is that 1 and 2 are supplementary, so they add together to be 180, and 3 and 2 are supplementary. So if they're supplementary, it means they add together to be... Nope, you got it right. 180. Complementary is 90. Equals 180. It doesn't do much. And both of these are by the definition of supplementary angles. Both of these are by the definition of supplementary angles. Because it also told us to us. Definition of supplementary angles. So I have a feeling y'all are about halfway across the page, yes? Okay. So y'all still have room because we still have 1, 2, 3 things left, and we can curl down if we need to. And as I said earlier, I said the bubble, the flowchart proof's a little bit nicer. Because so far, the fact that 1 and 2 and 2 and 3 are supplementary angles, do those really connect to each other? No. Do these here really connect to each other? No. But what we do know is that since these both equal 180, what I can say is I can take both of these together and say what? That angle 1 plus angle 2 is equal to angle 2 plus angle 3. And they say measure, and if we were doing this specifically in a proof, you would need to put measure. So we have this here, and this is our transitive property of equality. So this here, we can show that these two things come together to give us the next one, yes? That's why I like these flowchart proofs, is that we can have multiple things that are working towards the proof written out separately, and then we show where they connect, where they go together. Well, from here, we can say what? Angle 1 is equal to angle 3. This here would be our subtraction property of equality, because we subtracted what from both sides? Angle 2. And you can write that under it. So last but not least, angle 1 is congruent to angle 3 by definition of what? Congruency. It's also written there in the, or congruent angles, definition of congruent angles, because we're talking about angles. Since we're talking about angles, it would be definition of congruent angles. And that's it. So we didn't have a whole lot of room for that, but that's all we have to do here. We were just converting it from one to the other. Now, there's also a third type of proofs, which is a paragraph proof. A paragraph proof. Which is pretty much saying given angle 1 and angle 2 are supplementary angles, and angle 3 and angle 2 are supplementary angles, then measure of angle 1 plus the measure of angle 2 is equal to 180, and angle 2 plus angle 3, the measure of those angles equals 180, because definition of supplementary angles. So you guys don't have to write this down, but you can. Are you seeing this flow of how this is working with the paragraph? Yes? Is this any different than what we did with 2 column? No. Is it any different from flowchart? It's just I am listing out each individual step one at a time. Given this, this is true. Then This is true because this reason. So definition of supplementary angles. Therefore, angle 1 plus angle 2 is equal to 180 because our transitive property of equality. Hence, angle 1 is equal to angle 3 because the subtraction property of equality. Therefore, 1 is equal to the measure of angle 1 is equal to angle 3 because the subtraction property of equality, I think I said that twice. Then 1 is congruent to angle 3 because of this. So it's almost we're explaining it one step at a time. It's just written out. So that is another way to prove these. So this here isn't the whole proof, but it's just I put it down so that at least you can get an idea. Questions on this here? Last thing we're going to look at today. Linear pairs and vertical angles. Linear pairs, as we already know, make a straight line, yes? If they make a straight line, they add up to be 180. We know that one. Vertical angles are congruent. So if two angles are vertical angles, they have the same measure. So let's look at an example of this here. So looking at this here, I'm told that the measure of angle 1 is 117. I want to find the measure of angle 3, angle 4, and angle 2. So what angle is a vertical angle to angle 1? 1 and 3, because they're over the top of each other, yes? Opposite pairs. So the measure of angle 3 is what? 117. 1 and 3 are vertical angles, so they have the same measure. Angles 2 and 4 are vertical angles, yes? So whatever their measure is, it would be the same. We could do that. What do we know about 4 and 3? Do they make a straight line? Yes. So 4 and 3 add up to be 180 because they are a linear pair. Since 4 and 3 make a straight line, we can say angle 4, the measure of angle 4 plus the measure of angle 3 equals, well, I know the measure of angle 3. It is 117, yes? So what can I do? I can subtract it from 180 and find out that the measure of angle 4 is 63. So that leaves us with one more to find, yes? The measure of angle 2. Well, what is the measure of angle 2? There are 3 missing angles. There are 3 missing angles right there. Let's look at another one. So we need to find the measure of angle 1, measure of angle 3, and the measure of angle 4. Is there one of these angles that we know for sure without doing any calculations? Which one? 4. What is the measure of angle 4? 59 degrees, because 1 and 3 are vertical angles, 2 and 4 are vertical angles. So they have the same measure. Vertical angles have the same measure. Huh? So we could say that 4 and 3 equals 180. Well, this time I know that the measure of angle 4 is 59 degrees. And we can do what? We can subtract it from measure of angle 3 is equal to, so 1, 6, yep. It's going to be 121 degrees. Because 121 plus 59 is 180. So what does that mean the measure of angle 1 is? And that's it. That is all we have to do for this here. Any questions on this here? Are we good with this here? Yes? I have a feeling y'all feel pretty comfortable with this one here. So if we were to work it out, so we had 88. Well, 2 would be 88, and 3 would be 92. If we calculated it out, it should be 92. I'm just going to go on and give you those there, because I feel like y'all are comfortable with this here. Yes? Yes? Okay. So let's do this one here. Okay, so this one here is not actually asking for the value of this angle. What is it asking for? So I know that this angle is 148, and this here is 3x plus 1, yes? Are these two angles vertical angles? So that means they have the same value. They have the same measure. So what do we know that 3x plus 1 should equal? 148 degrees, yes? So now we can solve for the value of x. Well, we need to minus 1 first, because I need to get x by itself before I divide. This would be 147. Then we can divide by 3 exactly. So x equals 49.
I got that anyway.
Mm-hmm.
I think the reason.
So this is going to be the easiest way, because the only other way to do it is to find out that this here is 32 and then set these equal to 180, which isn't any more easier than doing this. So if we have this, we'll set them together because they're equal. Now, we have this here. I want to do this. Mark that number out and do this. So if you went on and solved it, that's fine. That is perfectly fine. I'm just creating a new example problem that we're going to look at, because it could come up in the homework or on the test that we don't have a number. We just have variables. We're still solving for it. But what do we know about these two angles here? They are equal. So really what we're saying here now is that 5w plus 3 is equal to 2w plus 12. They're equal, so I can set them equal. Vertical angles are equal. Vertical angles are equal. So the first thing we would need to do is to get the variables on one side. So do we want to move the 5w or move the 2w?
2W.
By subtracting 2w from both sides. This 2w minus 2w would be 0. 5w minus 2w would be 3w. Now we need to get w by itself, so we would subtract 3 from both sides. I get 3w is equal to 9. We would divide both sides by, and w would be that's it.
I said, isn't 3 substitute with these two?
3 is just the value of w. So if I wanted to know what this angle actually is, well, even to find those, I still need to figure out what this angle is. Because we'd have to do 5 times 3 plus 3. Well, 5 times 3 is. So this angle here is 18 degrees. This angle down here is, and what do we know about these two angles here? They add together to be 180, so this would be 160, 162 and 162. I think in the other one, I think some of y'all worked it out and got 19. Yes? Yeah, so 19, if we plugged it in, it would give us a more realistic answer. I just picked something off the top of my head. Do this here, so to show you that we can do this. Questions on this here? We good with this here? Now, I'm going to just show you this here, because it could be that this here is 6x minus 4, 3x plus 21, and have this here. Are the vertical angles, do the vertical angles have the same variable? Well, no, right? Because one of them has W, one of them has X. But what does? What do we know about two angles that make a straight line? So if I wanted to solve this one here, I would set 6x minus 4 plus 3x plus 21 equal to 180, because I know two angles that make a straight line add together to be it does, but if I set it equal to 360, I have an equation with two variables. We can't solve an equation with two variables. But here, when I do 180, I only have one variable. Then we can minus 17 from both sides. Then we get 9x is equal to 163. Divide both sides by 9. And we would get an ugly fraction. I'm going to leave it as 163 over 9. And we could solve the other one for W. It's not going to make sense. This one here is not going to work out because, again, I did not take the time to plan this problem. Does that make sense? So the value of X and W will not be put back in here so that they all add up to 360. Or the angle that has W and the angle has X would match up possibly. So I'm going to stop it there because, again, I'm going to confuse you if I finish this problem out. But this process, how we could do it if the variables of vertical angles aren't the same, is doing this here. Okay? Yeah, that's fine. And this here is the last page of the notes. So what we've covered two column proofs. Yes? We've covered today. So hold up. So today we covered flowchart, and then there's paragraph, which we discussed a little bit. Yes? There will be one question on the homework that's about paragraph. You're not having to actually write the whole thing out. It's just filling in the blanks. So I threw that in there to see if y'all could do it. But the rest of it, the test will not have a single paragraph proof. All right, guys. Have a good rest of your day and complete